Good afternoon, guys. Welcome. Dan here from Industry IoT. Today, I'm joined by George, who is the CEO of Foundries. Welcome, George. How are you doing?
I'm good, thank you. Hello, everybody. Hope we're going to have an interesting chat today.
Absolutely. Just a quick introduction from me before I hand over to George, and George can introduce himself properly. But just a quick rundown on the format of the session. George will be delivering a presentation, so he will share his screen shortly. We have got a couple of poll questions that are built into the presentation, so you'll see the slides appear on your screen. We can actually vote live in the session, so we will be launching the polls live. So please keep a lookout for them because we are interested in what the results are going to be. The session today is actually scheduled for 90 minutes. George will be delivering the presentation initially, and then we are planning to go into an interactive Q&A and a group discussion. So at the moment, you guys are behind the scenes, backstage, and you'll be watching the presentation. But a little bit later on in the session, when we go into a discussion and we start asking some questions, we would like some of you to join us live on video and get involved in the discussions. I can promote you as panelists at any point. So I can speak to you behind the scenes, and if you are happy to join us on video and get involved in the discussions, then great. If anyone has any questions or queries, you can message me privately via the chat room, or if there are any problems. But apart from that, George, I'll hand over to you.
And you've got a chat room that everybody can post chats to?
Yeah, absolutely. So there's a chat room that everybody can chat in, and there's also a separate room for Q&A as well.
Right, and if either of them appear, then and I need to stop and answer some questions, let me know as we go along, because I'll be probably focusing on the slides.
Yeah, no worries. I'll be in the session the entire time with you. So if there are any questions that pop up, I'll give you a nudge and I'll let you know. All
right, so welcome everybody. My name's George Gray. I'm CEO of Foundries.io. And today we're going to talk a little bit about some of the challenges that I think everybody faces in terms of the use of IoT and edge, and particularly as it applies to sort of manufacturing and industrial applications, Industry 4.0 and so on. Very quick background to myself. I've been in the industry for a long time. I originally ran a company called Tadpole Technology. I originally did an electrical engineering degree, ran a company called Tadpole Technology that built the world's first workstation notebooks. So we built the first Sun workstation in a notebook back in the day. And I've done a number of things since then, including spending 15 years in the United States, running a company that built a mobile operating system funded by the carriers before Android came along, and more recently spending 10 years as CEO of Linaro. For those of you who are not familiar with Linaro, it's the company that was founded by ARM and others to work together on open source software for the ARM ecosystem. So it's been very involved in everything from IoT to the Linux kernel to ARM servers. And in fact, Linaro has been consistently in the last 5 years in the top 5 contributors to the Linux kernel. So Foundries was formed by a team out of Linaro, and we can talk a little bit about that if you're interested during the discussion phase. But this presentation is more about the sort of state of the industry rather than Foundries itself. So what are we here to talk about? So firstly, Linux. Most of the focus of what I'm going to talk about is some of the challenges when you're building products and deploying Linux in an IoT or an edge device in industry manufacturing, but it also applies to any actually Linux implementation. And talk a little bit about some of the challenges, particularly as you go to very long-term support. Talk about security and how we deal with it, and then also talk about potential strategies for if you need very long-term maintenance, by which I mean more than 5 to 10 years. So why am I qualified to talk about this? As I mentioned, Foundries was born out of Linaro. a lot of experience in open source, but also in the team in everything from boot software, Linux kernel, security, cloud, and how to connect everything together, and lived with a lot of the challenges in the ecosystem in terms of actually building real product devices for use in the industry. The team is expert in Linux and connected devices in general, everything from kernel, security, standards, communications, over-the-air software, and back-end cloud deployment. And our vision is really to reinvent the software platform for IoT on every architecture, Intel, ARM, even RISC-V, and to solve existing industry challenges in terms of fragmentation and security, which we'll come on to. So in terms of industrial IoT and manufacturing, Linux is clearly a standard for pretty much all devices, whether it's robotics, whether it's smart factory applications, vision systems. Behind all of these things is Linux. And I'm guessing most of the companies that are represented on this call, you have a lot of Linux being built or being deployed in equipment in your existing facilities, but also I'm guessing in equipment that you're selling to customers. But this also covers everything from smart devices, buildings, cities, robotics, automotive, transportation, healthcare devices, anything that you build with Linux and anything that you use internally in your organization in Linux in a manufacturing capacity is sort of kind of covered by what we're going to talk about. And why do people use Linux? Well, proven operational stability. It runs most of the servers in the world. In server configurations and enterprise configurations, when it's used for the stock market or running Facebook or Oracle, end-to-end security is very strong. It is proven as a very secure platform because it's open, because everybody can see it, and because there's a lot of attention paid upstream to making Linux secure. And it has a very vibrant and long-term ecosystem. So everything from integration of AI and machine learning for factory type operations and industrial operations, time-sensitive networking, bringing real-time capability into Linux, SE Linux for securing, adding additional security and audit capabilities to the basic platform, and increasing use of virtualization and container technologies, particularly in enterprise, but even moving down to devices, and we'll talk a little bit about that later. And the fact that Linux has long-term support, which we'll talk a little bit about as we go along, and overall a low cost of ownership and consumer choice, customer choice in terms of actually deploying Linux compared to commercial products. So the first question is just to sort of establish how many, sort of what kind of audience we have here. As an estimate, because I appreciate you probably don't know exactly, but what is an estimate of how many Linux platforms or different kernels or different implementations of Linux do you have in use across your company today? And some of you represent very big companies globally, so this is just a simple wild ass estimate, so a simple swag here. So if you'd like to answer that question, you basically have about a minute before we move on.
Yep, people are voting live now. Almost everyone has voted already. Most are leaning towards 10 plus. George, I'm not sure if you can see the results live on your screen.
No, I can't.
Okay,
I can't
no worries.
see the results.
So as it stands, 10% say 2 to 5, 30% say 5 to 10, and 60% say 10 plus.
That doesn't surprise me at all. In a previous life, actually in Lenaro, one of the companies we visited and spent a fair amount of time was with Cisco, and they had obviously built a lot of their organization by acquiring companies. And with every company, they got more Linux platforms. So this is not an uncommon problem. Okay, So can I get rid of that? Yes. Okay. So what is the problem we're going to talk about? Well, firstly, one of the biggest challenges is there's no platform for IoT and edge devices. There's no equivalent for Windows on a desktop or Android for mobile. And the reason is everybody's product is different. Everybody has different hardware. Everybody has a different use case. So it's very difficult to create a single platform that works for everybody. Open source is free, kind of. It's actually very expensive to produce, but maintaining your own Linux platform is very definitely not free. And every time you create a new Linux product anywhere in your organization, effectively, you're supporting your own distribution. We'll come on to that in a minute. Linux is highly securable, but expertise in security is very scarce and is in high demand. And a lot of companies deliver Linux products that, although they may think they're secure, they're not. And most IoT companies have experienced a security breach. And this is an increasing problem, not a decreasing problem. And then LTS, long-term support, does not meet the needs of industrial users. And I'm going to talk a little bit about why and what we can do about it. Okay, so this scenario can happen to anyone. A zero-day vulnerability, which basically means that with a security flaw has been found and has been notified to everybody. It may have been known behind closed doors, but it's publicly now announced, and everybody must scramble to fix their product. And you wake up and you've got a manufacturing line running 24/7 because you've got a critical customer deadline, and it's just stopped. And your 3-year-old robotics lines running Linux software, basically they've been hacked. And you've got a security team, you're a big company, they've been up all night, and they tell you they think the problem is a recently reported zero-day Linux kernel critical vulnerability, which we're assuming is called Megazilla. This is obviously a simulation. Now, the interesting thing about Megazilla was that a patch was actually posted. This vulnerability was discovered a few months ago. And the mainline maintainers have been working on it because obviously it affects everybody, including the stock market and everybody who uses Linux. So the mainline Linux kernel has been fixed already and was posted. The patches for this were actually posted about a month ago. So what happens next? Everything's okay, right? Well, it kind of depends. Firstly, how do you do software updates? If you can't, then obviously you're in trouble. So we won't spend too much time there. And in most, depending on whether it's a customer product or whether it's your own manufacturing facilities, you may not be able to do over-the-air updates. You may actually have to send a service engineer out. You may have to do a product recall. This is becoming increasingly not an option. And hopefully, your manufacturing systems and everything else are able to be updated securely over the air. If not, your life is not going to be very easy. But let's assume and hope that you have done this, and if you haven't, you should be thinking about it for all your future products. So the next question is, what Linux kernel are you using? Well, I said in the beginning, the robots were 3 years old. So it's likely that your Linux kernel is probably more than 3 years old, because generally we don't update Linux kernels unless we need to. But actually, this probably doesn't matter because you're going to find that there are bigger problems that you've got in this situation. And what I'd like to explain is that the idea of an LTS kernel, and for those who may not have the detailed knowledge of this, so Linux, when you use Linux in your product, you have a kernel, and then you have your user space, which is all your utilities, and then you have your applications, which are either running directly on the kernel or they're running in containers, for example, if you use container technology. And LTS is a way that the Linux community maintain the kernel. So because people don't like to change their kernel, there's this thing called an LTS kernel, which stands for long-term support. So long-term product support is obviously a good thing. helps customers, avoids and delays product obsolescence. You get the longest lifetime you can out of the product. But an LTS kernel on its own, or an LTS project on its own, doesn't actually mean that you're necessarily protected. Stability depends on the whole software stack in your product. And any software on your product can be exploited. If you remember a few years back, and we're still living with the consequences of it, there were critical bugs called Spectre and Meltdown, which weren't even software bugs. We're in the software business, and I like to say that even if we could write perfect software, which obviously we can't cater for the fact that the hardware might not work as it's expected. And these exploits, Spectre and Meltdown, were found in the hardware and needed software workarounds to fix them. So LTS is supposed to help solve this. And the cost of LTS increases over time. And the use of LTS can actually give you a real problem, which I'm going to outline in a moment. But before that, let's just talk a little bit about the SoC vendors themselves. These are the chip vendors and how they view this. So they try and help, because for the companies that you're buying gateways or you're buying your products from, the components that you're using, then what you find is that the SoC vendor is actually supporting what's called a board support package on their chip that is ultimately in your Linux platform. And the kernel community support LTS kernels for 6 years. So if you think about that, if you're supporting the kernel for 6 years, and there's an LTS kernel every year, there's actually 6 kernels you're supporting at any one time, because they do annual releases. And then SoC vendors have multiple SoCs. So if you think about somebody like NXP or TI or ST or Qualcomm, having, say, 5 families of chips with different cores and different custom peripheral IP is not unusual at all. So that's 30 board support package builds that SoC vendor's got to support at any one time. And it's not just the Linux kernel. Every one of these SoC vendors has large amounts of proprietary code that they have to support in the kernel as well. So inevitably, these board support packages lag LTS kernels. So just because something's being fixed upstream doesn't mean it's available to you immediately. It can be many, many months before you get fixes if they support your particular kernel at all. And therein lies a big problem. So in the real world, what's happening is that you need to make choices early in the design process whenever Linux is involved, or any operating system or any piece of software. Because if you think about the ARM ecosystem, there's variable support for these chips upstream because everybody can't support everything. But if there is support upstream in the Linux kernel, then you can leverage that LTS support directly. If you are using the latest kernel, it will get fixes. If you need the vendor's board support package, so from Qualcomm, TI, ST, and so on, then you also depend on them and their own software schedules. And then if you've added your own kernel changes because you have some proprietary technology that you've put in the kernel, then you need your own long-term maintenance strategy for that too. And I'm just using the kernel here as a particularly sensitive example. This actually really applies to all of the software that you're putting into a product. So next question, last poll, is what's the longest you're going to need to maintain software in a product that either you're using or for your customers? Is it like a consumer appliance or a mobile phone, perhaps less than 5 years support needed? Is it 5 to 10 years, 10 to 20, or very long term, 20 plus years? I'll give you a pause for 20 seconds for that one.
We've launched the poll, so people are voting as we speak.
Okay, how are we doing?
Yeah, it looks like everyone has almost voted. So at the moment, we are 58% saying 10 to 20 years, 33% saying 20 years plus, and 8% saying 5 years, up to 5 years.
That's pretty scary. Okay, good, excellent. And you're going to be, hopefully this is going to be a lively discussion when we get there. All right, so excuse the picture. What happens after LTS ends? So we've got 6-year maintenance. The kernel's maintained for 6 years. What happens then? Well, either the in-house team has to continue supporting these products for the long term, or you basically need to have somebody do it for you. And the cost of doing this for every product is rising each year because the complexity of maintaining and backporting to older kernels gets harder and harder. So in this example that we're using at the moment, the kernel is fixed upstream a month before the vulnerability was exposed. But you've now got to go and look at every one of your products, and that fix uses the latest software. Now, if you've got a kernel that's 5 years old, because your product is 5 years old, the way of fixing it may not work because there may not be the underlying code, because it may use relatively new features in the kernel, may not work in that kernel that's 5 years old. So you may have to do some really complex work to take that fix and put an equivalent fix into your product. And this gets harder and harder over time, and we're finding more and more critical vulnerabilities, not even necessarily software bugs, as I said. These can be hardware challenges as well as products get more and more complex. And there's little reuse of code because your kernel in your product is unique to you. There's also less demand, there's less supply than demand for people who want to go and work on this stuff. And increasingly, we're seeing more and more engineers, software engineers coming out of university, going into cloud development. That's where all the excitement is. That's where all the interest is. Embedded engineers are getting hard to find. And so as a result, many big companies particularly, but any company using software in the long term, find themselves really unable to maintain product software. And this increases the risk of business disruption and brand damage from malicious attacks, which, because we're now connecting everything to everything, is getting more attractive to the bad guys. So we've got this sort of imbalance between how we've traditionally done LTS software and what the reality is as we're deploying these new products that we're expecting to last for longer and longer. Okay, let's get back to our 0-day problem. It's a day later and the production lines are still down. And the security team has been looking at what the heck's going on. And the good news is that for this product, you are actually in the LTS window. We use the LTS 4.14 kernel. Today we're on 5.10. With support until 2022. So 4.14 was actually first released 6 years ago, 2016. And we're still in the LTS window. So we also think, good news, we can over-the-air update the fleet in the field, but there isn't a patch yet for Megazilla because the upstream patch doesn't work on 4.14 and the Linux maintainers are still working on it. In Spectre and Meltdown, it took over a year to get all of the LTS kernels supported after the problem was announced. It was only fixed in the upstream kernel when the product was announced. And then everybody scrambled to try and fix it. But it was, the further back you go, the harder it gets. And it's not properly fixed and well tested in a lot of old kernels today. So the second problem is we also need an update to the SoC board support package, but of course the vendor has the same problem. If it hasn't been fixed upstream, then they can't take the patch and then even start to do the work themselves. So this puts more delay. And the final problem is actually we've never tried to update it because we've never had a problem until now. And even worse, we've received a ransomware demand for $50 million and our business is at risk. Our customer is screaming and things, it's a bad day. Okay, so what went wrong? Well, you've probably got the message by now, but isn't this what LTS is for? Well, yes, it is, but here's what happened. Megazilla was fixed. in the latest software before announcement. Next, the upstream maintainers, people building and maintaining Linux, the community, need to backport these patches to all of the previous LTS kernels. That can take a lot of months. And in this case, it was a complex fix. It hasn't been done on all of the old kernels yet. But we had to announce it because there were threats that the bad guys were going to start using it on real life products. After that, the SoC vendor then needs to update their software. And as we said, that can take more months. And after that, you as the OEM need to reintegrate all this, retest, rebuild, incorporate any changes that you've made, go through validation, and you've got a lot of work to do. So we've got a problem. So what's the alternative? How can we maintain products for 20 or more years? And the answer turns out to be that the fact that we're connecting everything to everything is creating a whole bunch of new industry challenges, but the ability to over-the-air update software easily changes everything, as long as you can do it securely. So let's just talk a little bit about over-the-air updates. Over-the-air updates scale from small numbers of devices to millions of devices, right? There are plenty of examples in the consumer space, your iPhone, your Sonos system, your TV, that are being updated regularly. But these OTA updates must be secure, or they're just introducing new exploits. And the first thing to think about when you're deploying an OTA update system is the update system itself secure? Well, the good news is there are some well-established open industry standards for this. And the one that is fairly widely used is called the Update Framework. And this is a Linux Foundation, Cloud Native Computing Foundation rather, project. And it's a threat modeled specification for how to do secure updates properly, and involves keys and rotation of keys and security and so on. It's used by big guys, Microsoft, Google, Amazon, Docker. And there's a separation of trust. It actually assumes that you could be compromised, and it can address compromised keys by revoking them and rotating them. And so you have a set of keys in your product that sit above the original root of trust installed by the manufacturer yourself. And if those keys are compromised, then you can rotate them. And this work was originally funded by the US Department of Homeland Security, and there are open source implementations of this framework that can be used. So assuming you've now got secure OTA, it changes everything. And the key here is hope you never have to use it. And there are some applications like mobile phones where you want to deliver new functionality regularly, but there are some applications like a configurable robot on a manufacturing line for 20 years, where ideally you hope you never have to actually change the operating system. So the reason OTA changes everything is because it gives you a lot more flexibility. You can develop on remote devices because you can just over the air update them. And if they fail, you roll back, you fix what you get a report, you can fix it, you can try and update again. Testing can be carried out on any device. And in fact, production devices can be turned into test devices. You can run tests on production devices. And new software can continuously be integrated and tested on products anywhere in the world. And you can deploy OTA updates based on your product, your use case, your process, and market need. Just because the software is being updated and you're testing it doesn't mean you have to deploy it. There may be regulatory reasons why you don't want to deploy it. Maybe often there may be operational reasons. But in the case of our example, you want to deploy it as quickly as possible. So until now, how do we do things? We basically use in-house engineering or third-party companies to build Linux. We leverage LTS open source software projects where appropriate, because we get all the benefits of Linux and the ecosystem. But today, it's a bit like mobile phones, hence the picture. Would you really go and develop a new mobile phone today without using Android? No, you wouldn't, because it's free, it's available, it's got millions of hours of runtime on it, it's stable, and it gets updated, and it's what you would use. But before Android came along, mobile phones were pretty difficult to build, and not many companies did it well. And arguably, you could argue the same today about IoT and edge devices. It's very complex. Everybody tries to do it themselves, and a lot of people don't do it well. And what result is, everybody is building and maintaining their own unique platform in every Linux product that they're shipping. And this is actually a huge cost of ownership and technical debt. Even if you've done it right, and even if you've done it perfectly, you don't benefit from anybody else because it's your unique product. Nobody else cares about your unique product. So you're not benefiting from, in Android, the fact that every Android phone, every bug, every problem goes back into core Android and makes the product better and better. And then we have the problem of scarce and expensive expertise, as I said, that you need to maintain your own software platform. So you've got a big team that's just maintaining this plumbing that's complex, requires a lot of expertise, and isn't actually adding value to your product. What you really want your engineering team to be doing is focusing on your own IP and value add, and not on maintaining Linux. And those of you who've said you have more than 10 Linux products in the field or in use, look at how big that team is that's doing all of this. It's a lot bigger than it would be if you had a platform underneath that was non-differentiated. So costs increase exponentially over time as old software is no longer supported for the reasons that we've talked about. And honestly, zero-day exploits are a risk to everybody today, and that risk is getting worse. It's both a business risk, but it's also a brand risk if you're actually selling products based on old kernels. So what options do we have? Well, there is a new way, but it involves changing some of the way that we think and operate in the industry. On the other hand, it's about time, because we've been developing embedded products basically the same way for about 20 to 30 years. And it's time we really caught up with what I would call modern technology, and particularly cloud and enterprise technologies for how we build, support, and maintain these products. And it basically is the principle is that the most secure and most tested software is the latest software. Now, the latest software can carry risks because it's new, but in Linux and in the platform that we're talking about, this latest software is deployed globally. It's deployed on servers. It's deployed runs the stock exchange. It runs all of the big consumer servers in the world, Facebook, Microsoft Azure, the back ends that power the cloud today. This software is robust. And it's exactly that software, that kernel, that ends up in your product. So go back and think about this and say, okay, this is the most secure and most tested software in the world at the moment against the bad things that are happening and the vulnerabilities that are being found in the kernel. And yet we're still running kernels that are Linux 2.x or 3.x in an awful lot of products. This is really not a good idea. 20-year examples: smart city buildings, infrastructure, some smart appliances, electric cars, much longer lifetimes than using internal combustion engines, and factory automation, obviously, factories, buildings, infrastructure, so on. So if you're going to connect a product to the internet, let's actually look at the software that we need. And it's not just the kernel. You really need to look at your supply chain across the entire spectrum of software that you're using, and consider how many vendors you're using. So the chip vendors probably supplying the boot firmware. You may be using some kind of trusted execution environment, some kind of security company who's helped you. You may be using a hardware security module. And this may be being used for things like financial transactions, key storage, cryptographic operations, and so on. Your kernel and drivers are coming from some kind of distribution or from an in-house team. You've then got a user space and distribution, might be Ubuntu, might be CentOS, whatever. And then you've probably got some kind of containers or application platform that generally will be from the same company provided you the distribution. And you've then got your own services and applications. You also have a device deployment and management system of some kind. Maybe you're using Amazon or Google, or maybe it's in-house, or maybe it's third party. And then you've also got an OTA update system, which either you've bought as an add-on or it's part of one of the previous things mentioned. And then you've got to consider maintenance of everything. And you've also got to consider, is the entire stack secure end to end? We're giving ourselves an awful lot of problems if we go and buy this from multiple vendors. It's very hard, and this is even for relatively simple IoT devices these days. It's really hard to ensure security if you're getting all of this from multiple vendors. And the goal is a maintained platform, ideally, like Android for mobile phones, for everything except your IP. Think of yourself as the phone manufacturer. Really what you want to focus on is your differentiation at the applications level and to delight your customer. You don't want to be focused on how on earth do I get the kernel updated in my phone or the firmware updated in my phone. So use the latest software. Sounds simple. Hardware may last 20 years. Software generally doesn't. Focus on end-to-end security and an over-the-air solution for all of the device software. Use open source software where possible because the cost of ownership is lower. There is this network effect of everybody making it better, and you don't end up with too many issues in terms of the current global challenges of export licensing and supply chains, where if you use something that's been developed in the US, then you may have trouble actually deploying it and using it in China, and so on and so forth. So open source software solves a lot of these issues. And if you have proprietary security stuff, that's great, but build it on an open source platform so that you can actually keep your IP separate and owned by yourself. And then work with vendors who provide tooling to support your own customization at any level. It's no use just buying something that you can't change because your use case is going to be unique to you. So the ability to provide a platform that you can customize is critical. And at Foundries, how we approach this is we provide such a platform, but we basically say anything you change, you maintain. But that's exactly the way it should be, because your value add and what your product is, if you like, your software, that's what you maintain. Anything that you've changed that isn't standard. And that way you can continue to maintain that piece and only that piece, and the platform will do the rest for you over a long period of time. And then actually release an update according to your own market and product needs, not your vendors. Just because your vendor is providing you an update, you have to decide whether to actually send that update to your customers or your piece of internal equipment. How do you achieve 20-year support? You basically do it by maintaining a build for your product with the latest software. Now, even if you never deploy it, this is a really low cost insurance policy, because once you've got validated software and you've done your first customer ship, it's actually relatively easy if you do it in small pieces and relatively low cost compared to any other way to keep the software up to date, because the platform keeps updating and all you have to do is make sure your software isn't breaking. And actually, this is an ultra long-term maintenance. This is all you need. If your product is capable of running the latest software, then if there is a CVE and there is an attack in 10 years' time, you have the head start and you don't have to catch up on 10 years, which is almost impossible. And it's a lot lower cost than paying for somebody to maintain your private piece of software for 10 years or having an internal team do this for every product that you produce. This is the most important slide in this presentation. If you can do this, then it's an insurance policy. You are always able to update your product, and you can always, if necessary, if there's a critical flaw or a bug or a CVE that you have to deploy, you can. So going back to our 0-day problem, at least somebody in the company was prepared, because in this case, what happened was that a new projects team did a proof of concept on a continuous maintenance solution, such as I've described last month, and they actually used the manufacturing line robots for the proof of concept. And what they've been doing is actually not running the software that's 3 years old. They've been running the latest Linux kernel and have been testing the whole software stack on production robots. And as a result, they've been updating the fleet overnight, and they've rotated new security keys as we speak. And so the hacker can no longer access the robots. So it all turned out okay, but only because they used the latest software. So that's kind of a quick overview of something that might happen, something that's actually realistic, I think, for an awful lot of products and companies out there today, and something that we at Foundries have set out to solve. But we want to do this in a way that is based on open source and is not a proprietary solution, but that is something that the entire industry can use, based on Linux and the latest open source projects across the industry, for over-the-air software update, for deployment, and then for long-term maintenance of software over very long periods of time. So I hope that was interesting and useful, and look forward to Q&A and discussion.
Thank you, George. Very, very interesting and very well delivered. Thank you. That was great. As most of you would have heard at the beginning of the session, there are a couple of options here now to get into some Q&A and some group discussion. There is a Q&A tab at the bottom of the screen, where you can post your questions. Alternatively, we can promote you as a panelist into the discussion live on video, so we can have a conversation here. I have spoken to a couple of you. Paul Hingley, who, if I'm correct, is the industrial security officer at Siemens, was happy to join as a panelist, who I am trying to bring into the discussion now. Bear with me.
There he is. Hello, Paul.
Hi, Paul. I think you're on mute. Yeah, you're on mute at the moment, Paul, if you can hear us.
Yeah, I can hear you now. Sorry, Zoom suddenly shut down and then I rejoined, so apologies.
No problem. Thank you for joining us. I hope you enjoyed the presentation, Paul. Do you have any questions for George directly, or anything to contribute, having tuned in and listened to the talk for the last 45 minutes or so?
No direct questions. Generally concur with the presentation and what industry and where industry finds themselves at the moment as regards the technology advancement that's taking place around Industry 4 or digital footprint, whatever you want to refer to it as. We as Siemens, we have a concept that has been built over many years, relating to the interaction of our products between each other. So the automation requirements, development solutions that we have defined over many years have generally been based on industrial protocols and the interaction of industrial products within utilizing those protocols. The world of IoT is something we've been working on now for around about 5-6 years, with the advancement of what we've termed as MindSphere, which is our platform as a service. And around that, again, continuing that consistent integration of our products right through the various elements of control that we get involved in. So generally concur with the comments that were made within the presentation.
Yeah, I think it's interesting looking at the industry as a whole, and there's this, I think, migration of, there's going to come this, Tyler Baker, our CTO, likes to say, if you think about developing a big web service 10 years ago, you would basically go and get a whole bunch of web server, rack servers, you'd build the whole platform, you'd build your application, and you'd then serve it to the world. If you're creating a web service today, you can do it from Starbucks, right? You do everything in the cloud. You go and get your compute instance in the cloud, your deployment in the cloud, and you do it all virtually. And if you look at product development using Linux today, we're doing a lot of that the same way we did it for a very great many years. And we see the deployment and development of software moving more and more to the cloud over time, and just being a service like buying a compute instance on Amazon. You'll be able to just, and this is what we're doing at Foundries, we're basically creating this open platform that people can just literally in the cloud build their next Linux platform for their whatever product they want to use. The other thing we're seeing is an increasing use of container technologies in the embedded and connected devices space, because that allows better separation of services and applications. If you look at things like the Linux Foundation EdgeX project, but you can then the deployment of things like microservices, doing this in containers allows you to actually separate the underlying OS and firmware from the applications and services. But even then, it's very important that you need to be able to over-the-air update both, using ideally the same back-end software platform to do that update. And what you find is you can update containers, i.e. your own applications and services, without rebooting the core operating system and platform. Whereas if you've got everything built into one blob, if you like, in your application, in your end application, and then you have to update something, you have to update everything. Incremental updates are also your friend.
Yeah,
maybe.
Yeah, I mean, again, there are do's and don'ts within the automation layer. We work within timeframes and specific timeframes for the transfer of data. So if we're looking at a traditional automation system, we're looking at overall refresh rates of less than 350 milliseconds. If we're working with safety, it's less than 150 milliseconds. And if we're working down in real time, it's less than 10 milliseconds. So the use of on-premise solutions, or whether you call it edge devices, etc., is going to become a major part of the way that we develop automation systems of the future. One of the other areas that we see is going to be of really primary interest for users will be platform-to-platform comms. There will be multiple platform operators and vendors out there. But again, we come back to the time frame. So if you're looking at safety, it's really critical, whether it's safety critical or safety relevant. And the combination of that, what has been good in 2020 is seeing that 62443 as a standard has now been incorporated into 61508. So we're now seeing safety standards actually being applicable also to what's developing in security. And we're a great advocate of 62443. We believe that that answers a lot of questions around the automation layer and the way that automation systems are designed and delivered, whether that's down in the physical technology concept using security levels 1, 2, 3, 4, or whether we're looking then at the processes and policies and procedures that sit alongside it in the maturity levels. But at least then we are making sure that there is a governance approach into the way that these systems are being orchestrated and developed. And that's the critical part of this, is that, yeah, it's great having the comms. It's great being able to visualize these new concepts of interaction. But there's still a piece of and a lump of metal that has to move, for example, on a robot.
Exactly.
And if you get hit by one of those, I can assure you that that is not the best thing to be hit by. So from a safety concept, from an engineering concept, those traditional values and conservatism that's built into the design still has to be maintained. That's quite critical as well.
Yeah. Hi, George. Just to step in there, you may have seen we've got a couple of our participants have now joined the discussion as panelists. Hi, Suzanne. I think you're on mute at the moment. I'm not sure whether you can fix that, but Suzanne is one of the senior. That's right. We can hear you now. Suzanne works for the National Institute of Standards and Technology, bringing a slightly different perspective into the conversation. So I was keen to get her up as a panelist and to get her involved in the discussion. So Suzanne, I'm not sure whether you have any direct questions to either George or Paul, who's been speaking recently, or anything at all to contribute to the discussion from your side.
Well, I think the other reason I was asked to be here is that I am chairing for 62443 for ISA 99, a technical report on incorporating industrial IoT, which is giving asset owners and integrators technical guidance on the questions and things that they have to think about, the new risks, et cetera, when they are incorporating IIoT, but they are also in an industrial setting and they want to be in compliance with 62443. I will say that one of the big areas that we're starting to have a lot of discussion on, and we're actually probably going to have a significant amount in, is an area that we call trust in cloud, which is the recognition that when you incorporate IIoT, you are generally doing it what we call IIoT CBF, which is IIoT with cloud-based functionality. So you're essentially trusting the cloud for a certain amount of your security. And so we're talking about how working with vendors under 62443, there are certain things that you can think that a vendor might do that you might have to depend much more, for example, on contractual agreements and service agreements than where before, if you weren't using IIoT CBF, you would be able to have direct controls. And then we have we also have a discussion on how controls change depending on what you're doing.
Yeah, no, I mean, it's the whole, this is an increasingly complex world we live in. And I think that there are things like attestation and trust that are needed at the very low level to make sure that the software that you are, that you've either received in an update or that you're using at the time, because somebody may have changed it on you overnight, is actually the software that it's supposed to be. And the good thing about all of this is that we kind of do understand, quantum computing notwithstanding, we do understand how to secure software and how to sign it, so that, for example, if there's a software update, there are some obvious things that you mustn't do. You mustn't be able to roll back to an earlier version, because otherwise, if there's an exploit, you can roll back to an earlier version and use the exploit and abuse it. But you also can relatively easily, through a platform, as long as you're using a secure platform for the delivery of software down to your device, you can actually secure each update to the target end device. So each update is secured with its own public key, and only that software update will only be unencryptable and readable by the actual end device that it was designed to be to fix. Even if you've got 1 million devices out there, each of those actually carries.
You say that as if it's such an easy thing to do.
So it is doable, but then you've got to consider it's doable today. The challenge that you have is if you do have 1 million device fleet, let's just say hypothetically, what you don't want to do is be sending 1 million updates over the internet from the cloud to each device. That's kind of a big use of bandwidth. Whereas what you really want to do is have the ability at the edge, as Paul was saying earlier, to have services that say, actually, a lot of this has to be on-prem, because you may actually deliver secure updates, 1,000 of them to 1,000 gateways, and each of those gateways may then actually do the subdivision and deliver the 1,000 updates individually to each of the devices. Or if it just depends on the level of security you want on the end device, right? And a part of it is, if it's a home light bulb, it's a very different situation from a safety critical system. And the comment you made earlier, Paul, about safety critical systems, I wanted to go back and talk about a little bit about safety and Linux. I think autonomous cars are and autonomous vehicles are a really interesting first use case for this, which is in the industry, which is accelerating solving a lot of these problems. where we all really understand that the compute for an autonomous car is millions, if not hundreds of millions of lines of code, and is never going to be safety certified in the way that we safety certify low-level software. And so how do you deal with that? Well, basically, you accept that that is not safety certifiable and is actually unsafe inherently. And then on bare metal, in terms of the raw processor, you run a safety certified microkernel or virtualization layer or hypervisor that you can safety certify. And then your compute is effectively Linux based. But interestingly, because that's usually where all the power and the SOCs and the communications with the outside world is, you then have safety critical RTOSs, and you have this in industrial equipment or healthcare applications as well. You have a safety system which is running on a little safety certified RTOS, and you have to be able to update that as well. But that's still okay, because you can use the Linux connection to the outside world to bring in an encrypted and signed secure update to your safety operating system that, again, only that operating system can actually decrypt, because it's all in the safe world. It's all in the trusted world. So these architectures are rapidly coming to the device level. But I think, Paul, what you're really talking about more is what is being dealt with by standards like EdgeX and these other kind of virtual services layers that are happening in containers on edge devices and servers.
Yeah,
rather than the bare metal robot.
Yeah, and that's generally the types of processes that we see in manufacturing. Hence the reason that edge devices will become more important. They will become more of a considered part of any application that we put forward. But you're also going to see that transition of control, especially around safety critical and safety relevance devices, into that level of automation around the physical layer. And it's at that point that the same levels of engineering have to be applied. And these are some of the concerns that we see from customers when we're talking about this leap into this new world of IoT. We're still governed by the Health and Safety at Work Act. We're still governed by the Machinery Directive. There are lots and lots of layers of protection that's been built in over many years to ensure the safety of the operation itself and also the safety of the operatives that are working them. And what we have to do is to have this transition, but also have it managed to ensure that all of the existing conservativeness that we've always had around the untrusting of systems is maintained. And I think that's the problem you've got with the discussion, is this trust environment, the trust of these new devices and new systems that are being developed against the traditional methodology that has been there and developed over many years.
Sorry, Suzanne, go ahead, sorry.
I was going to say there are some standards that aren't there yet. For example, there is no standard currently on software signage on using software in that way. There isn't currently a standard out there, so you don't know if the implementation by the vendor in signing their code is in fact a good and reliable way to sign it, because there is no standard that they can point to and say, well, we're using this standard, we're using a NIST standard, we're using, well, a NIST guidance, we're using an ISO standard, we're using, ITEF. It's not there yet, which also leaves the asset owners and integrators in somewhat of a precarious state.
Correct, yeah.
I just want to introduce Roberto very quickly, because he's joined us live as a panelist. Roberto, you are on mute at the moment. I can see the little icon. Roberto is the head of Machine Center of Excellence at SKF Group, and he had a question around the artificial intelligence. But Roberto, I'll let you ask the question.
Yeah, okay. Thank you, Daniel. So very interesting discussion so far. George, very, very, very nice presentation. Thank you for that. He's an open-minder. then is a question to you, George, but also to you, Paul, because, you know, we are working also with Siemens a lot. You know, I am building, you know, machines and condition to make the machine intelligent. So I comes to a very practical questions. It's a little bit like the robot line, you know, you mentioned before. Is more and more frequently that we are building, you know, artificial intelligence software, which are maybe using standard software, but you store at the edge level, which is working local, and which is, you know, I confirm is more and more important, all the edges devices. And you can activate microservices like, you know, the different Dockers, whatever. So if for this kind of software, which are containing a lot of, you know, important and, specific information, and which are, you know, working with algorithm finalized the single problem, that's the level of the security is even more important, because you are not you giving outside the data, but also the law to put together. So is the OTA, you know, support working in this way as well for edge device, or we are to think a different kind of maintenance of assurance for to maintain the level of you know, secrecy? That's, to me, is a very practical question. If you can comment on that, I appreciate.
Yeah, absolutely. And the answer to your question is yes. If you use the right OTA software system, you should be absolutely able to protect your own IP. So how we address this is we essentially say, look, we're providing you this platform with these security capabilities, which are documented and implemented to industry standards by security experts and can be reviewed by security auditing companies, but they're built to industry standards and they're built by some of the best security minds in the industry. And so then what happens if you have your own proprietary technology is you effectively own your proprietary technology. It's your code, and it can be kept from everybody else. It can be kept in a air-gapped room if it's that secure, if you were talking about military stuff. When it gets to the update, you then need to be able to basically create your own image, right? Your final image for your device. And you then need to be able to encrypt that with a signature that only you own the private key, and only you own the private key, and you sign it with a public key. So at that point, that update is completely secured and can only be read by somebody who has the relevant key to be able to decrypt that using your public key and using their public key. So it actually doesn't matter that you have proprietary technology in there, because you will know that only the device that you've intended to be used to run that new algorithm can run it. So you remember earlier I said any production machine can be a test machine. One of the things that's really cool about this technology is effectively what you can do is over the air, you can actually deliver a completely new build with a new kernel and new proprietary algorithms, new everything. And only that device you have sent it to can actually even decrypt that update. Now, when they have decrypted that update, you then have the choice of running your sensitive algorithms in either the secure world or the non-secure world, depending on the capabilities that you have on that end device. But typically you can have encrypted file systems, you can have a lot of additional protection to make sure that even if somebody has physical access to the device, it's still very difficult for them to access your technology.
Okay, thank you. And this is valid, you know, per device or per group of device? I would say if I have...
Both, you can choose. Yeah. You can choose, right? So you can go down to individual devices, or you can have fleets, or you can have a combination of both. You can have a key for a sort of fleet update that you're not too worried about, that it doesn't matter if one's, you don't care too much if one's compromised, you don't care if all of them are compromised, or if you are extremely cautious, then you would have a different key for each device. And that would be in a situation where you were concerned about not having leakage if one device was compromised.
Okay, okay. Thank you, George.
And the other thing is, as I said, when you have got a compromised device, you need a way of recovering it. And therefore you need a strategy. And there are various standards around how to do this. And the one that I identified in the presentation, TUF, the update framework, look it up. It's a pretty interesting specification. As I say, it was originally developed by the Department of Homeland Security, and it's since been used for also doing something called Uptane, which is another specification for updating actually traditional automotive products where you have what are called secondary ECUs. So if you think about it, the way cars are built today, unless you've got a Tesla, is there's a whole bunch of processors all around the car, the ECUs, the engineering control units. And then there's a sort of central processor that maybe runs the IVI and talks to the outside world. And so if you can over-the-air update the software to your car, it typically comes into that main SoC, which is the main ECU. And then what Uptane does is it uses the same TUF update framework specifications, and it's been threat modeled to sort of withstand nation state attacks and a whole bunch of different types of attacks, and they're all documented in the specifications, which evolve over time. But that actually has the capability of also securing secondary updates, which is kind of a little bit like what we were saying earlier about being able to pass an update down through Linux into, and then have your really low-level software, your safety certified software, be able to actually take an update for a safety critical system and actually do that update securely as well. So you can go down to this, as Suzanne was saying, there's specification, there are not yet open international standards that describe how to do all of this, but there are standards that are being implemented where they are threat modeled and they can be audited against by security companies. And those do exist today. And but we need to align internationally. And the nice thing about open source software, of course, is you can actually build references for these specifications. Black box software is generally not a good idea in the security space.
Thank you. Thanks a lot.
Hi guys, I'll just take a moment whilst there's a break there to introduce Doug. Doug McKnight has joined the discussion as a panelist. Doug is the Manufacturing 4.0 Director for Dow for the EMEA region. Hi Doug, how are you doing?
Hi, good afternoon everybody. Yeah, Doug McKnight here. I'm based in Wiesbaden, Germany, working for Dow Chemical and looking after implementation of Industry 4.0 solutions for Dow.
Excellent. Doug, do you have any, based on what you've heard and what you've seen this afternoon, do you have any direct questions for George, or perhaps any comments to make to the discussion that you've been listening into?
Yeah, so I mean, I'll be very honest and say a lot of the software-related information goes right over my head. My background here as a customer and as somebody who spent a large part of my career in running process industry operations and now in the implementation of IoT technologies into those operations, is really that, you know, these technologies are coming into our portfolio of tools, particularly IoT sensors in the field, and that gives us as a user community, as a customer, a lot of new potential to get new information about our processes, and that's a good thing, whether that be sensors for traditional instrumentation like temperature or pressure, or new types of sensors that give us additional ways of seeing things like manual valve positions or wall thickness or other things like that give us new pieces of information about the process. When we put this information out there, of course it comes into our processes in a new way. Traditionally, any chemical plant has a very secure core process control network where the important process control instrumentation and actuation for, you know, safety systems for running a chemical plant is very well isolated from the general internet. These systems, of course, you need to have a sensor in the field. You need to recover the data from it from the likes of LoRaWAN or other communication protocols, and then get that back over internet providers. Of course, as an industry, that begins to concern us from the point of view of cybersecurity and what does that mean in terms of the vulnerability of our internet network. And this topic then plays right into that. In the core of it, we may well in 10 years' time have tens of thousands of sensor devices out there of various ages. And how do we ensure that those sensor devices and the operating software within them at the edge of our periphery, if you like, does not open us up to a serious cybersecurity threat or attack. And you know, we talked in the middle of the presentation there about the potential of having a ransomware attack. You know, one of our greatest potential scenarios of cybersecurity is having somebody actually have the ability to actuate a valve on an operating chemical plant from outside of the fence line. So those things are very important, particularly therefore the longevity of the long-term support. You know, for a chemical plant that we built in the 60s and we're still running in 2020, then you can understand that it's important that we have longevity in the reliability of our assets, and these new assets are no different from that. We've got to have something that can continue to operate securely and give us that information, you know. And you know, some of these devices are obviously the battery powered, so after 5 years or whatever the battery life is, that we have to replace them, or at least replace the batteries. But within that life cycle, we would not expect, therefore, to incur a cybersecurity threat from.
Yeah, I think it's interesting working particularly with legacy devices, because it's becoming increasingly interesting in Industry 4 and for maintenance and predictability to add a bunch of sensors into an existing legacy product, gather all this data, get it sent up to the internet, process it with AI and ML algorithms, because there's a huge amount of data potentially available, and you can see some things that we've never been able to see before. But then the interesting thing is taking action from that data means going back to the device and, as you say, flipping a valve or turning something off or turning something up because it needs to be tweaked. And at that point, you suddenly realize that actually everything I've just talked about, from getting the sensor data into the cloud, processing it in the cloud, getting it back down to the actuator, you've got to be totally assured that all of that is completely secure, and there's no point in that chain of suppliers you've used to actually, or you've got to do the whole thing on-prem behind closed doors, right? Which is also the other option, right? And other people are doing that.
Yeah, that's our major problem. Traditionally, that's a sensor, a cable, a computer, and back to another sensor, and now multiple layers of internet provider.
And multiple wireless and so on. Suzanne, I've got an interesting slightly related question for you, and it comes from sort of some of my experience in the mobile space, interestingly, which is, if you think about mobile phones before Apple came along, the carriers had specifications that the mobile phone manufacturers had to follow, and they were sort of this thick, 6 inches thick, of what you had to do and so on. And updating, you couldn't update any of the radio software at all without going through the ISO standards, and the carrier standards said basically you couldn't update your software. And then and also that you had to follow every single legacy piece of messaging information so that you could swap messages with other phones and so on. So it was a major industry issue, and Apple came along and basically tore down the rule book and said, well, we're going to ignore half of this because it's no longer relevant, but we're actually going to be able to update our phones, and therefore we've got a level of security in there. Now, clearly, the same thing doesn't apply to industrial, because in industrial applications, and what you've just said, Doug, and what you've said about safety critical stuff is your phone generally isn't safety critical, but your robot on a manufacturing line potentially is, and an autonomous car certainly is. What worries me slightly about some of the standards that exist today is the same problem of how do you prepare if there is a real emergency to throw away the rule book and be able to update something because the result of updating it is lower risk than following the existing process and rules that you're under. So should standards urgently be starting to think about, is there a level at which the time and safeguards that we've got mean that we're actually, in the event of a 0-day problem, whatever that may be, but a 0-day software problem that has to be fixed, is there a process in these standards for being able to say this is an exception and we need to be able to deal with it? Is that being thought of as these standards are being put together?
Well, standards, especially 62443 and most of the standards that are currently coming out, are risk-based. So they always say if the risk of doing something that is not in compliance with the standard, for example, if you need to download something right now, but we already deal with 0-day vulnerabilities in IT, in traditional IT.
Right.
Under the standard.
In traditional IT, that's true, yeah.
There's already those rules. I think the question that standards would tell you to ask is not, don't do this, but what is the risk of doing this? And is it less than the risk of getting this fixed? For example, in terms of a safety critical system, is the possible risk of it not performing well when you download the update, you apply the update, is that less than the risk of someone exploiting it until you have time to test it? And that's a very complicated question, because that comes down to your trust in your vendors, your trust in the source of the update, your perception of the risk to you. For example, we were talking about on-prem, but if you're a pipeline, there's no such thing as on-prem, right? The majority of what you're doing is wandering off in the wilderness. So you would have a different risk calculus than a chemical plant. And what standards tell you to do, and standards have to be moved back from regulation, et cetera, is look at the risk and make a decision with your eyes open, knowing what it is you're going to gain and what it is you stand to lose. And in your case, risk would probably say, the standards would probably say, well, if you're going to forego best practices in terms of testing before you apply, or whatever the best practices that is enshrined in the standard, you should have some idea of what you're going to do if it goes wrong.
Susanna, sorry, Roberto here, concerning what you said, this means that in a way we have to establish or to understand the compliances of the software against the different standard. So, go to vendors which are providing this kind of certification, this kind of compliances, which is cutting a little bit the interesting market of small, software house which are developing a fantastic solution everywhere. So could you comment this aspect? So, the big vendors certifying against the standard and the small local software house which are giving software for a solution in which maybe we cannot guarantee a certain, insurance for the risk of safety.
Well, I think if what you're talking about is how you send an update securely, how you get a software update securely, that's not really a standard. That's an understanding of how to apply cryptographic mechanisms to an update, to get an update out. That's a combination of how you originally constructed the thing you're trying to update, how you construct your software update process.
Okay.
And so you have to, it's no good to think about those things once you have an emergency. You have to have thought about those things.
We have to.
So even a small software company should be able to think about those things and set them up and then use them. It's not, this is not like the kind of lift that we ask in safety, for example, where there's, you have to do the HAZOPs and there's a lot of regulation around this and a lot of compliance that you have to go through. I mean, if you're a small software company, you should be able to look and say, if I'm going to update my product, then the product needs to be designed to be updatable in a secure way, and I need to be able to deliver those updates in a secure way to my customers. And as a customer, you should ask them, how do you intend to do this? And they should be able to tell you, well, this is what we do.
Good point. Very interesting. Thank you.
Hi, Paul. I can see you trying to talk, but I think you're on mute.
That's a real issue, and that's utopia. The reality is that we are seeing IoT devices being implemented now down into the physical layer that have no mechanisms whatsoever, either from a maturity level control or they're from a technology perspective for updates. So these products are being installed generally around proof of concepts with no real understanding for a mitigation policy going forward, whether that be safety orientated or from a technology perspective. And that's a real problem for industry. It's a real problem for industry to start to understand, again, back to this traditional conservative approach that industry has, because for many years they've inbred an in-depth DNA which relates to minimizing that risk. We're moving into a world that says, well, risk doesn't matter. Well, risk still does matter, and they need to be applied correctly. So if you're talking, like Doug was talking there, about pharmaceutical or chemical industries, if you're looking at producing an update, some of it is legislative updates as well that you have to comply with. There are licenses that are applied to the process itself. So you can't just do an update. You have to go through and understand what the overall process is. Likewise, if you are updating a product that's on a machine, the update could effectively change the operational duty of that product on the machine. And you then end up with another scenario that occurs. There are multiple problems they're sort of evolving at the moment with regards to IoT. And some of the traditional methods still need to apply, because we're not talking about devices like typical inductive sensors that have been around for many years. What we're seeing now is some of these sensors that used to be low functionality are now actually becoming things like an edge device itself. And if they become an edge device with intelligence, with AI that are built in, it brings in another complexity into the sensor that you have to manage. And I think the standards community needs to look at it and really be careful a way that we don't want to starve innovation, but at the same time, innovation also has to be it has to be guided. There has to be enforcement around that type of innovation. And
one of the issues.
Sorry?
I was going to say, Paul, one of the issues that we found when we were going through working on this TR was the way 62443 is developed.
Yeah.
It doesn't assume multifunctionality devices.
Yeah.
And it doesn't forbid them, but you have to think differently about the standard to do exactly what you say, which is you get a multifunctional device. Yeah. In fact, we're pointing out in the TR that you need to think about the functionalities that the device has that you're not using.
Yeah. Yeah.
Because they still exist on the device.
Exactly. And that's what we do. So the way that we apply 62443 is that we have TRAs in process right from the scoping of the system right the way through to the validation and verification process at the end. And that way, then you have an agile TRA that lives with the project and lives with the products that you're using as well. And security by design then becomes a part of the DNA of the project and the solution delivery. And that's something that is not adhered to when you're looking at third parties, smaller companies. We have the luxury of having a big conglomerate behind us that supports us. But smaller companies are going to have to really consider their maturity level management of their systems, processes, and product, as well as the technology they use as well.
Hi guys, just to jump in a second there, we do have a couple of other people that have joined us as panelists. Heiko from Rolls-Royce, how are you doing? Good afternoon.
Yeah, good afternoon. Hello, sorry for joining late.
No problem at all. No problem. Keen to get your thoughts, or if you have any questions from what you have seen so far, or maybe any comments you have about some of the work that you're doing with Rolls-Royce on this topic.
Yeah, absolutely. I mean, following intensely the discussion and coming from probably one of the most risk-averse industries, aerospace, I can tell you there is a big, I would say, natural resistance in having edge devices which can be basically, which are not secure or are not isolated. So stopping production in any kind of way is something which certainly should not happen, as well as taking information out of anything we do for aerospace, which needs to be very safe. So I think what has been said in terms of the required standards, I think the standards are very important, but there is a big barrier to entry for smaller companies to actually get it, or smaller software suppliers to get into edge devices which are secure and delivering the software. So the question I would have is, first of all, where are we on having a one standard rather than 5 or 10 standards to enable this? And have there been discussion with some regulatory bodies already, which, for example, our regulatory bodies, FAA, EASA, etc., would accept, recognize, or buy off? I think that's a valid question from our perspective.
Yeah, I think so. We are, in terms of our expertise in delivering a Linux-based platform and making sure that that is open and visible to all, but meets the required security standards for running these operational services and things on top is what we do. And therefore, the problem that we're solving is essentially the fact that everybody who's building any kind of product on Linux is basically doing it yourself at the moment. And this is a recipe ultimately for disaster. And so this concept of how do you create the windows for IoT? And the answer is that you can't, at the binary level, you can't create an image that runs on every gateway or every IoT device. You nearly can. I mean, you can take a server implementation and run it on an edge device if that's your edge device. But if your edge device is a specialist piece of hardware that uses LoRa or uses something that you can't necessarily connect to your big x86 box, and you need a custom piece of hardware, you're developing your own software. And so our strategy on this is to create this sort of minimal, secure, lowest common denominator that everybody can use as a platform, but then allow everybody to actually customize it according to their own requirements, whether they're safety requirements or whether they're air gap requirements, whatever it is. They can actually make those modifications, or in the industrial IoT space, things like time-sensitive networking for real-time applications. All of these changes can be made, but you then own the changes, or you get them back into the open source project, in which case they automatically flow back. When you're talking about process, then you need to make sure that from a standards point of view, the process for changing that software and responding to CVEs, because if you think about Linux, you're not just getting it from one person, that's coming from a whole bunch of different open source projects that are being maintained by often one individual somewhere in the world. And that's ultimately flowing into your product. It's also flowing into the systems that are running, as I said, the stock exchanges around the world, and some very important social media platforms that people are going to get very upset if they come down. Probably not as upset as if your airplane comes down, but even so, we've seen some challenges in that space as well. So I think that having an open source common platform is becoming increasingly critical for the industry, and then the mechanism for keeping that platform updated in terms of where do those CVs come, what is the process for getting them into the product, how do you identify to a vendor, this one really doesn't matter, right, for your application, or this one is absolutely critical for your application. And then the other thing that's happening in the open source industry is a growing up of recognizing that when there are these exploits, there may need to be a period where the vendors of this low-level software are given access to the information about the exploit so it can be fixed before it becomes publicly known, and so that people are able then to update their software. Because any of you running Linux anywhere in your organizations, if there is external access to it, and if it is not up to date, it is at some level of risk. Now, at the moment, depending on your own internal security procedures, that can be very, very minimal. But I'll give you a scary example where things like cars typically have 10-year-old Linux in their IVI connected to Bluetooth these days. And there've already been examples of Teslas and Land Rovers and these and cars that are fixed with software that people can get into from externally, being exploited. Now, typically there's a combination of sort of people who do it for fun and then will tell everybody, and then there are people who will do it to try and extract money and damage you. So I think we've got to all work together on this, both at the services level that you were talking about very early on, Paul, and then down into the standards level that we were talking about more recently. The whole industry has to recognize that we're going through a period of change, and we have to put process in place to make sure that according to what product that we're delivering and using, we have as much safety and security as we can, but that we also understand the level of risk we're taking so that you can make the right decisions for your own product and your own service. Because if you take no risk, you can't get anywhere. That's innovation versus risk.
No,
right?
no,
Absolutely agree. I think that is important, that we need to encourage innovation and probably take some boundaries away from production rather than flying. When you fly, you don't want anybody to deal with it. But I do think that's something, I think, where as a customer, probably a little bit more confident examples will be required to convince that there is more potential in the innovation rather than risk involved.
and that's what I was just going to say. It's that it's not stopping innovation, but it's developing an environment that innovation is still risk averse, and you can't just go into industry or into an industrial solution and not be understanding of that potential risk, so that the customer then believes and has a trust model with that innovation. Likewise, the users going forward have a trust model as well. And what we found in the early development of MindSphere, for example, and proofs of concepts that we did, was developing that level of trust. There are real issues in doing a very small proof of concept and then converting that over to a workable solution. And
I'll give you the scary example of that is people who do proof of concepts with Raspberry Pis because they're cheap and easy and anybody can get hold of them. Just do not go near anybody who tells you that they can secure a Raspberry Pi.
I've been there. Don't worry.
But on a slightly more serious aspect, I think the important thing we are a small company. Okay, we've come from big company backgrounds, so we understand some of these issues. But the important thing is that the customer, particularly if they're big customers with teams inside them that are able to audit this stuff, that they have all of the tools and information needed to be able to audit what's being supplied to them. And that's a lot easier for a company that's providing open source software than it is for a company that's very concerned about its own proprietary algorithms and so on. So part of what we're building is around incorporating the latest technologies around auditing, logging, attestation, and being able to actually configure the product with the security level that you want, so that when it actually goes into your organization can basically take that technology and say, okay, this is the area that we are concerned about. We need to go and see how this was built, or what is the difference between this and what's available in our current system, and so on. And then, I mean, from our point of view, we're fortunate enough that I think this is becoming a really well understood problem across the industry, that fragmentation and security issues are really slowing down the widespread adoption of IoT and the benefits that it can bring, which includes companies like yourselves, because it's not ready for prime time use in a very secure environment yet. And how do you solve that problem? But we're fortunate enough that we have one or two very big customers who are out deploying over the next 12 months millions of devices. And once you get to a platform that has that level of deployment, if it's in the same kind of area as you're using yourselves, then there's a level of security in that, well, everybody's using it. On the other hand, you get the corollary of that, which is that if something goes wrong, it affects absolutely everybody. But you have to pick your poison, right?
Hi guys, just a quick one from me. We have a gentleman that has been waiting behind the scenes, but his camera hasn't worked, so it's been difficult to bring him in. But Eric, can you hear me?
Yes, I can hear you.
There we go. Hey, how you doing? Eric is one of the global leads for security for OT and IoT at Thales. Eric, I know you've been waiting patiently. I've been trying to bring you into the discussion without interrupting anyone, but keen to bring you in. I know we're a little bit tight for time, but any questions that you have or any thoughts you have, having listened to the discussion, you know, we'd love to hear them.
Yeah, the product you mentioned and all the discussion is about secure by design, which is obviously important. Cyber, and especially in operational environments, is a multi-headed dragon running years behind the IT development. Has your product incorporated any possibilities to integrate into SOC monitoring?
Yes, there's a couple of interesting technologies that are appearing in the industry. There's SOC monitoring in hardware, which is starting to be offered by some vendors into the SOC vendors themselves, so that at the hardware level inside the SOC, you're actually monitoring for software problems and intrusions. Like, for example, at the very simplistic level, an out of bounds can be actually tested in hardware on the bus in the chip. The other things you can do in SOC monitoring are in creating, obviously, runtime testing on the binaries that are being executed. That has an impact, and there are several companies that have that kind of technology that you can basically just build into your platform. Either you have to recompile, or in some cases you can actually just compile their software and then it will watch the executing code and make decisions accordingly. The more traditional way of dealing with the safety critical issues are to basically execute anything, like the obvious example in the consumer space is credit card transactions, and where you store credit card information and personal information for GDPR in European products. That kind of information is typically handled in a secure application that only happens in the secure world. So it's very difficult for anything that's in normal user space, which includes the kernel itself, to be able to get access to that, because that's executing in a secure world in a trusted execution environment, either on secure hardware or in a secure area on the SoC that's not accessible to any of your normal code. So there's solutions ranging from technology actually being built into the SoC to monitor the code execution stream, all the way through to things that you can put aftermarket into your builds.
All right.
I can't remember the name of the company.
Yes, thanks for the explanation. What we see, we are, as Thales, are also running systems 20 years and beyond due to military applications. The secure by design, the whole NIST approach, like explained, it's risk driven. On the other hand, you cannot foresee everything, so real-time monitoring is the other head of the dragon, I always say. So you integrate the possibilities for SOC monitoring, real-time monitoring in your products.
Yeah, it's so we would use a third party typically to provide that software functionality. And there are several companies that have specialized in doing that. The other thing is you basically can turn on a certain amount of switches. Linux has, as you I'm sure know, has an enormous number of knobs and switches, and you can basically implement SE Linux and then have auditing, real-time auditing and logging of events and set levels at which you actually want to raise an alarm or worst case reboot the system or just stop. So you've got a number of options for how to monitor in real time execution that come as part of Linux. But again, there are third parties who provide this the technology that I think you're talking about, which is actually monitoring in real time the code that's being executed on the SoC and looking for either anomalies where the code isn't working the way it's been working for the last year, or is looking for a particular errors in code like buffer overflows or spectral meltdown attacks or whatever it may be.
Yeah, that's what I'm looking for. All right, thanks for your answer.
Yeah.
Okay,
Right,
excellent.
well, I think we're pretty much out of time.
I was going to say, yeah, we've ran over a little bit, but that's always a good sign of a good discussion. So thank you very much for delivering the presentation, George. It was great. Paul, thank you for contributing to the discussion this afternoon. It was good to have you involved. Eric, good to see you. The session has been recorded, so we can share it with everyone involved online today, and of course, anyone that wasn't able to make it live. But any questions for me at all, George?
No, thank you very much for hosting and organizing this. And if anybody does want to get hold of us, website is foundries.io, and I'm just George at foundries.io. So happy to continue the discussion with anybody who'd like to, but I hope this has been useful for everybody who attended. Thank you.
I'm sure it has. Thank you very much, guys. Have a great afternoon. Take care.
Yes, thank you. Bye.
Bye.
Bye.